Hi, friends. So let's see if we can fill in this story for you. So basically, the formula that I just kind of told you, it has a story behind it. And so we're going to tell the story as to how they came up with it. So first of all, there was someone out there who had a job to do, and they had to add up a bunch of terms of geometric sequences. And they got to the point where they were sick of doing it term by term because the lists were really long. And they tried to figure out if there was a formula they could use instead. And so let's show what it looked like when they did it term by term. So if it's geometric, if your first term's A, your second term would be A times your common ratio. Your third term, A times your common ratio squared. Your fourth term's A times your common ratio cubed, etc. And it would keep going until you get to your nth term. So if your nth term was, if you're only supposed to add up the first four terms, then we would be done by now with that AR cubed deal. But let's say n was like 1008 or something, then you'd have to keep going. So the plus dot 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 means you keep going in that manner. And then since this is the first sum of the first n terms, the very last thing you'd add, which I'm actually going to add in some gaps that I didn't have at the end of the last video. But the very last thing you'd add would be the nth term. And so the nth term, which we learned in the previous lesson, would be A times R, to the n minus 1. I did leave a gap right in front of that because I want you guys to think through what would the n minus 1 term have been. And I hope it makes sense. That would have been A times R to the n minus 2. It's for what we're about to do, it would be good to kind of think that out. So there you go. So this is what it looks like if you have to do it term by term, right? But the point is to come up with a shortcut. So the person that came up with this shortcut basically did a fun little trick. So in the next line, we're going to multiply this entire equation that we have here. We're going to multiply both sides by R. So on the left side, instead of S sub n, it would say R times S sub n. And on the right side, we'd have to distribute R into every single term. And so let's get started. So what would you get when you multiply this A by R? You get AR. And so I'm just going to go ahead and write that down, but I'm multiplying that by R, but I'm lining it up underneath this term. So now what would you get when you multiply AR times R? Yep, you get AR squared. And when you multiply AR squared times R, you get AR cubed. And then when you multiply AR cubed by R, you get AR to the fourth, but that would have been kind of lining up with something in the plus dot dot dot. So I'm just going to say plus dot dot dot. When you multiply AR to the n minus 2 by R, think about properties of exponents. You'd end up with AR to the n minus 1. When you multiply A times R to the n minus 1 by R, you get A times R to the n minus, to the n, sorry. And then right before AR to the n minus 2, implied in this plus dot dot mess, would be A times R to the n minus 3. When you multiply that by another R, you get that. Okay, so why did I line it up like that? Because the way to prove that formula up there would be to now subtract these two rows from each other. So, that's not a straight line at all. Okay, there we go. Okay, so on the left side, let's do the easy side first. S sub n minus R times S sub n would just be S sub n minus R times S sub n. Now on the right side, we're subtracting the entire second row away from the entire first row. And so the whole bunch of stuff vanishes, preferably with sound effects. And then, but not everything subtracts out, right? There's some terms that will still be there. So the A would still be there. And then you'd be subtracting AR to the n from this guy down here that didn't vanish. Now what I'd like for you to do is look at this line of work that I have here with your Algebra 2I's and see if you can factor out a common factor out of the left side and out of the right side. So on the left side of the equation, the common factor is S sub n. And I'd have to multiply S sub n by 1 minus r to get this expression back. And what's the common factor on the right side? Yeah, it's a. And I'd have to multiply a by 1 minus r to the n to get that back. And we're one more move away from the full derivation of that sum formula right there. And all we'd have to do to get s sub n by itself is multiply both sides by 1 minus r. And we'd find out that s sub n is equal to your first term times 1 minus your common ratio to the nth power divided by 1 minus r. And that's where s sub n meant the sum of the first n terms of a geometric series. And we can consider this formula proved. All right, my friends. Now, before I forget, let's make it official. Let's put it in a memorization cloud. So this one takes more memorization than the other stuff. So make sure you know what it's for and make sure you memorize it. So this is the formula for the nth partial sum, just meaning you add up the first n terms of a geometric series. And the formula is that the sum of the first n terms is your first term times 1 minus your common ratio to the nth power divided by 1 minus r. All right, my friends, do your best in times in your homework when you need to use that formula to make sure that you do it from memory. Remember to treat your problem sets like quizzes. It's all the more important in a chapter like this that is somewhat formula heavy to make sure that you kind of exercise that muscle as you go. All right, that's the end of the notes for section A3 part 2. And in the next lesson, we'll talk about the infinite geometric series instead of finite.